The unit circle of fifths. The unit circle is the circle whose radius is 1, hence a unit. Its center is at the origin of an xy plane, and we use it in mathematics to derive the values of sine and cosine through geometry and right triangles. Pythagorean theorem, anyone? The circle of fifths is a complete graph of all 24 major and minor musical keys. It's broken into 12 equal parts on the circle and orders each key by the number of accidentals, relative to C major and A minor, which have 0 accidentals. This results in the keys being ordered by intervals of a perfect fifth. The end result are the key signatures we have in music today. Click on the link in the video to learn more, math people. Before we look at this, let's explore the background between math and music. A great deal of research has already been done to the relationship between math and music. Music can be described mathematically in many ways, and a knowledge of this has been hugely beneficial to musicians. And you can follow this link to learn more. The beginnings of my research have been to try to turn this around. If you click here, you'll see the beginnings of my math and music research. My goal is to expand mathematics education by giving teachers more relevant and effective resources to develop mathematical thinking into students whose interests lie beyond it. I want math and music to collaborate. Michael Blake wrote the Pi Symphony, so pi would have a musical representation. The problem with this is that it only considers 32 digits of pi and not pi as a phenomena in its entirety. I'm here to expand the musical relationship with pi using the circle of fifths. You can click the link to learn more about the circle of fifths here. The framework for music as we know it today has been prominent since the 1600s, an age of new discovery when mathematics was being developed as well. However, the framework and development of the unit circle, although it did not come from music theory, came later than the parallel music discoveries. Again, you can click here to learn more. And now, the unit circle of fifths. The circle of fifths is broken into 12 equal parts for the 12 different musical notes. They're drawn on the circle at 30 degrees apart and represent the number of sharps in any given key. Similar to a mathematical formula, major and minor scales have formulas so that no matter what note you start on, you create a key in the same way. Because of this, you need to alter some notes. There are 12 musical notes total, but each scale has 7 different notes in it. Then the circle of fifths is formed by adding a sharp every 30 degrees. I've labeled the first quadrant of the circle of fifths in a similar manner as the unit circle, complete with functions, input values, and output values. The number of sharps on the circle gives us input, and applying either the major or minor function results in one of the 24 keys. So we can pair the sine and cosine functions on the unit circle to the major and minor scale functions or formulas. The output, like the graphs of sine and cosine, are in an oscillating pattern that theoretically goes on forever. But again, in the same vein as sine and cosine, the most useful values to us exist in the first complete rotation around the circle, where in the music, the most useful values are only the first 7 sharps and the first 7 flats. 1 octave in music is 1 rotation around the circle, equivalent to 2 pi. This was a brief overview, but the research goes into much more depth and requires an extensive knowledge of either math or music in order to grasp the connections and make this a useful tool. That's why it's highly encouraged for math and music teachers to collaborate with each other in order to reach students with this mathematics most effectively. Studies have shown that studying music helps students grow mathematically, and I would assert that this research and upcoming research can use math to help students grow musically. To learn more, click here to visit my website.